Okay, everyone. Assalamu alaikum. So let's begin. So we were doing trigonometry, and today is the last session that we're spending on this. Now, this part that we're doing today is only part of IGCSE syllabus. It's not part of O-level syllabus. It's about solving trigonometric equations. Okay. In the last session, we covered a few things that we will be needing for today as well. Let me quickly remind you about that, about those things. So one was that you need to remember these exact values for sine, cos, and tan. You need to memorize what sine 0 is, what sine 30 is, what sine 45 is, and what sine 60 is, and what sine 90 is. And similarly for cos and tan, you need to memorize all of these values, right? For instance, if you have sine of 60, you should be able to recall that this is equal to square root of 3 over 2. Okay. Now, if your memory is good, you can just try to remember it as it is, this whole table. If you find it difficult to remember, we looked at a way that we could use to basically remember this, and that was that you can write down numbers like this. So if it is sine, for sine, what you do is you write down numbers 0, 1, 2, 3, 4, right? So these are the common angles. 0, 30, 45, 60, 90. You need to remember the angles that we're talking about. 0, 30, 45, 60, 90. In order to find sine of these angles, what you do is you write down numbers like this: 0, 1, 2, 3, 4. Divide all of them by 4 and take square root, and that will give you the sine values. For cos, you just do the opposite. You start with 4, 4, 3, 2, 1, 0. You divide by 4, take square root, that will give you the cos value. Okay. And then for tan, we said you can just do sine over cos. Whatever is the sine value, you divide that by the cos value, and you get the tan value as well. Okay. Now, that's one way to remember this. If you can remember it without it, just these numbers, you can do that, because for the non-calculator paper, you will need to remember these values. Okay, so that was one thing that we did. And then we talked about graphs of trigonometric functions. Graph of sine function, graph of cos function, and the graph of tan function. You need to remember these graphs. Okay, you need to remember these graphs. You need to remember that sine graph looks like this. It starts from 0, it goes to 1, and then 0, and then -1, and then 0. Again, you need to remember these values. In the calculator paper, you could find them using a calculator, but if it comes in the non-calculator paper, which is possible, what you do is you remember these values, that you start from 0, and then it goes to 1, the sine graph, and then it goes to 0 again, and then -1, and then back to 0. You need to remember these values and the shape of the graph. This is the shape of the sine graph. It looks like this. Okay, you need to remember the shape. And then similarly for cos, now sine is going like this. It starts from 0, and then 1, 0, -1, 0, right? The y values, they're going like this from 0 to 360 at a 90 degrees interval. This is how these values are going. Starts from 0, and then 1, and then 0, and then -1, and then 0. Okay. For cos, we have a similar shape. It starts at 1, and then goes to 0, -1, 0, 1. Okay. So sine graph starts from 0 and it goes to 1 first, and then you have this oscillating shape. Cos graph starts from 1. Okay, and then it goes to 0, and then -1, and so on. You need to remember these shapes. Okay, and these corresponding values. Again, these are the important values here: 1, 0, -1, 0, 1. You need to draw these, you need to sketch these exactly like this. Okay. Now, when we solve equations, one way to solve equations is using these graphs. So you will recall these graphs and remember, beyond this interval from 0 to 360, the graph actually continues like this on the left side on the same pattern. So for negative values, it continues like this on the same pattern. Similarly, beyond 360 as well, it continues on the same pattern. So beyond 360 on the right side and beyond 0 on the left side, the same shape continues like this, right? So it's a cyclic graph like this. Similarly, the cos graph as well, before zero, it goes like this and so on. So the same shape continues beyond these points as well. Now, when you have to sketch it, you just draw the middle part from 0 to 360, but just keep that in mind that beyond 0 and 360, the graph basically continues with the same shape, right? The same pattern continues on the right side and on the left side. And then we had tan. For tan, this is the important value. At 45 degrees, the value was 1. And then at 135, it's -1. At 225, it is 1 again. And then at 315, it is -1. And at 90 and 270, tan is undefined. So at 90 and 270, you have asymptotes like this, right? You draw vertical lines, and close to the asymptotes, the graph goes like this. It goes to either towards positive infinity or towards negative infinity. We understood in the last class why this happens, and we tried this using our calculator as well, that this is what the shape looks like. Okay. Again, you need to remember this shape and the important points. At 45, it's 1. Tan 45 is 1. And then at 90, it's undefined. So the graph goes like this. And then in the middle part from 90 to 270, this is the shape that we get. And then on the right side, we have this shape. Beyond this interval, in this case as well, the graph continues with the same pattern. So on the left side, for instance, to the left of 0, the graph would look like this. And on the right side, to the right of 360, the graph would look like this. So if you were to go beyond this interval, on both sides, the graph continues on the same pattern like this, right? So this pattern basically keeps repeating. Now you need to remember that this graph starts from 0 and it goes towards positive infinity first, and then the rest of the shape of the graph, you need to remember all of that. Okay, now that's important to remember these shapes and the values that you have from them. Now, using those graphs, what we can do now is we can solve different types of equations. Okay. Now, let's understand how that is going to be done. First of all, let's do it for the cos function. Let's solve some equations that involve the cos function. Now, what I'll do for that is I will quickly draw the graph of cos function. You should be able to recall this graph and draw this right away. What does the graph of cos look like? It starts from 1. So it's going to be between -1 and 1, okay? Let's mark these points, 0 to 360. You've got 180 in the middle. You've got 90 here, and you've got 270 here. So the graph starts from 0. It goes to 90, and then 180, and then 270, and then 360. That's what the graph is going to look like for the cos function. And the shape, you need to remember, looks like this. That's the cos graph. Okay? That's the cos graph. This is what it looks like. Now, let's say you had to solve some equation involving the cos function. For instance, you might be asked to solve this equation, cos of x equal to 0.5. Let's say you have to solve this equation. And they're saying x is between 0 degrees and 360 degrees. So you want to write down all possible solutions for this equation between 0 and 360. Now, how are you going to do that? Now, normally what we do is we put this in our calculator, right? And the calculator gives us some value. Let's see what that gives us. Cos, so if we take cos to the other side in this case, that will become cos inverse of 0.5, right? Now, let's put that on our calculator and see what that gives us. Cos inverse of 0.5. Now, this is giving me 60 degrees. Okay, so that's one value of x that I'm getting from the calculator directly. This is 60 degrees. Okay, but the problem is, this is not the only value of x at which cos is equal to 0.5. In this interval 0 to 360, there will be some other value as well at which cos is equal to 360. In this case, and the cos is equal to 0.5. In this case, that value is going to be 300. Let me show that to you. Cos of 300, that also gives me 0.5, right? So if I were to input x equal to 300 here, that also gives me 0.5. Now, how do I find that other answer? That, yes, one is x equals 60, which we just found that from our calculator directly by doing cos inverse of 0.5. But what about this other value now? What about 300? How can we find that other value? Now, for this, we use this graph. Okay. Now, how exactly do we do it? How exactly do we do it? It says cos of x equals 0.5. This graph that we have drawn here, this is for the function y equals cos x, right? This is the cos x graph. They're saying cos x is equal to 0.5. So essentially what we're saying is the y value here of cos, it should be 0.5. Where's y value? This is 0.5 here, right? This is the y value for cos. What's the corresponding x value? Now, let's look at the graph. What's the corresponding x value? Now, this is one x value. Our calculator gave us this x value. This was 60 degrees. Okay, this is the value that we got from our calculator, 60 degrees. Now, is there any other value at which you have the same y value on this graph? You can go to the right side here. And you find another value here. At this value as well, y is 0.5. What's the corresponding value for x that we get here? It's this value. Okay. Now, how do we know what exactly this value is going to be? Now, this point here, how do we know what this point is? For this, we will use this symmetry of the graph. You see, the graphs are all symmetrical in a way. All the sine graph, the cos graph, the tan graph, they have some kind of symmetry. In this case, for instance, you can see whatever is the distance from 0 to 60 here, on the right side as well, you see it should be the same distance from 360. It's starting from 1 here. On the other side as well, you've got 1 here. So whatever is the distance from 0 here of this point, it's the same distance on the right side from 360. So what should this point be there for? 60 units away from 360. What's that point? That is going to be 300. 360 minus 60. This point is 300. So we say the other value of x that we get for x here is 300 degrees. That's the other solution that we've got. So this equation has two solutions in that interval. One is 60 and the other is 300. Okay. Let's take another example. Now this was for cos x equals 0.5. Now let me take another value. Let's say you have cos of x equal to negative square root of 3 over 2. Let's say you got this thing. Cos of x equals negative square root of 3 over 2. You want to solve this equation. Again, you know that x is between 0 and 360. Now, how do we solve this equation? Again, put this on a calculator. Cos inverse of negative square root of 3 over 2. See what you get from that. Cos inverse of negative square root of 3 divided by 2. So I just put that on my calculator. Let's see what I get from that. This is giving me 150 degrees. Okay, so that's one possible value of x that I'm getting for this equation. Okay, so that's one solution, x equals 150. When x is 150, the solution that we get is negative square root of 3 over 2. All right. Now let's look at the graph again. This is the graph. So again, you can do a quick sketch. Let me do it again so that you can remember how to draw it very quickly. So it's a cos graph, right? So the cos graph, it starts from 1. So you have 0 here, you've got 360 here. Let's do a quick sketch of this. This is 180, this is 90, this is 270. Okay, so cos graph is supposed to start from 1, then go to 0 at 90, then -1, then 270, and then 360. That's what the graph is going to be like. What's the shape? It's going to go like this, and this, and this, and then finally this. This is the cos graph. Okay. All right. Now we have found one value, which is x equals 150 for this negative value. Cos x is equal to negative square root of 3/2. This is a negative value. So let's say that point is here, negative square root of 3/2. Right? It's some value in decimals. It's less than 1. Let's say it's here. Now, corresponding to this value, we have got one answer. We've got one answer here. What's that one answer? 150 degrees. This is 150 degrees. Now, do we have any other x value for this y value? We can go beyond here and we get another point here on the graph. What's the x value going to be here at this point? Again, using the symmetry of the graph, you can see whatever is the distance of 150 from 0, it's going to be the same distance of that other point from 360 on the other side. So 360 minus 150, what does that give you? 360 minus 150, that other answer is going to be 210. Okay, another way to use symmetry here could be, you could say, okay, 150 to 180, this is 30 degrees. So to the right of 180 as well, it should be 30. So 180 plus 30, that also gives you 210. So the other solution that you get here, again, using the symmetry of the graph, this other solution is 210 degrees. So that's the other answer that you're getting, x equals 210. Is that all right? Any confusion here? Any question on this? Make sense? Okay, let's take another example. Let's say we've got sine now. Let's say we have sine of x that equals square root of 2/2. We want to solve this equation. Okay. Again, they're saying we need to solve this for x between 0 degrees and 360 degrees. All right. Okay, now how do we solve this now? Now we need to think of the sine graph and see what that looks like. Now, in your syllabus, you only need to be able to solve it from 0 to 360. Okay. You can't have anything outside this interval. It'll always be 0 to 360. Okay. You will study more advanced equations and A levels later on. But for now, this is all that you've got from 0 to 360. Okay, now how do we solve this equation? Sine x equals square root of 2/2. We want to solve this equation. What does the sine graph look like? We should be able to quickly draw that 0 to 360. This is 180. This is 90. And this is 270. Okay. Now, what does the sine graph look like? It starts from 0, it goes to 1, and then 0 again, and then -1 and 0. You need to remember these values. Sine starts from 0. Cos started from 1, right? Sine has to start from 0. Starting from 0, it goes to 1, and then it comes back to 0, and then it goes to -1, and then it goes to 0. So the sine graph looks like this. This is the sine shape. You need to remember this shape. You need to remember the points. This is the sine graph. Okay. Now, how do you find the value of x from this? X equals sine inverse of square root of 2 over 2. Again, put this on a calculator and see what you get from that. Sine inverse of square root of 2 divided by 2. We get 45 from that. 45 degrees. That's the result that we're getting. This is one value. This is one solution of this equation. 45 degrees. Okay, where is 45 going to be? 45 is right here. This is 45. Okay. The y value that we're getting is this square root of 2 over 2. This is one solution that we're getting to this. All right, this is one solution that we're getting. 45 degrees, our calculator is giving us this one solution directly. Now the question is, how do you find the other solution? So what's the other solution going to be? This is one point that we're getting from the graph. If you go on the right side for the same y value, you get another x value here. What is this x value going to be? Again, we can use the symmetry of the graph. You can see that this part is symmetrical, right? 90 is exactly in the middle. So whatever is the distance of 45 from 90, it should be the same distance on the right side from 90. This should also be 45. 90 plus 45, the other point that we have here is going to be 135. That's your other solution. You say x is equal to 135. That's the other answer that you get. Okay. So these are the two solutions that we have, 45 degrees and 135 degrees. This is one way to use symmetry. You could also use symmetry from the other side. You can say, okay, from 0 to this point, the distance is 45. So from 180 as well, the distance should be 45. And that gives you the same result, which is 135 degrees. These are the two solutions that we have for this equation. All right. But now things get slightly more tricky. What if we have sine x equal to minus 1 over 2? Sine x equals minus 1 over 2. Now we need to solve this equation. Now, what about this? Again, the question will say that x has to be between 0 degrees and 360 degrees. X has to be within this interval. That's what the question is going to say. Now, how do we solve this? We put this on our calculator and see what that gives us. X equals sine inverse of negative 1 over 2. Let's see what we get from our calculator. Sine inverse of negative 1 over 2. What's that giving me? Negative 30. Okay, now calculator is giving me negative 30. The question says the answer should be between 0 and 360. We cannot go beyond that interval. Okay, now minus 30 is not in that interval. How do we think about this now? Again, let's draw the graph and see what the graph looks like. This is the sine function, right? What does the sine graph look like? Let's quickly sketch that. Again, you should be able to do it very quickly. Sine graph starts from 0, 1, 0, minus 1, 0. Let me draw that for you. The shape of the sine graph, it has to go like this, right? That's what the shape is going to be. Now, if you mark points so that it becomes slightly better looking, 0 to 360. In the middle, we are going to have 180. On the left side, we have 90. On the right side, we have 270. Okay, so we mark values at an interval of 90 degrees. Now, what does the sine graph look like? We've got 1 here, we've got minus 1 here. It starts from 0. It goes to 90. It goes to 1 at 90, and then back to 0, and then minus 1, and then 0. So you can draw a quick sketch like this. It looks something like this. This is what the sine graph looks like. Okay. Now, when is sine equal to negative 1 over 2, the value that we have found from our calculator is a negative value. Where is negative x value going to be? It's going to be on the left side of the graph. left side of the y-axis. So this is 0. Negative 30 is going to be on the left side here. It might be somewhere around this point. This might be, let's say, negative 30. Now, what does the graph look like on this side? Let's think about that. What does the graph look like on this side? If this is negative 30, I showed you that the graph is going to continue the same shape on the sides, right? The same pattern is going to continue. So on the left side as well, the graph is going to go like this. Okay, this is what the graph is going to look like on the left side. So what we are getting is that at this y value, which is negative 1/2, the x value, what's that? The x value is negative 30. This is the point that we have. When y is minus 1/2, we've got this y value. Corresponding to this y value, the x value is negative 30. All right. Now, what are the other values that we're getting on this graph? Let's look at them. Corresponding to minus 1/2 on the right side. This is another value that we're getting right here. And then this is another value that we're getting right here. How do you find both of these values? Again, use the symmetry of the graph. What's this distance? 30 degrees. Okay, this is 30 degrees. What you do is you say this distance here should also be 30 degrees on the right side. So the point that you have here is 330. Because this distance from 360 is also 30 degrees. Okay, this is one point. And now using the symmetry of the graph, using the symmetry of the curve, what you can do is you can say, okay, if this is 30, then what about this? This other point? If the distance from 360 was 30 from that side, here as well, the distance from 180 should also be 30. So this point is going to be 180 plus 30, which is 210. And the other one that we got from that side was 330. So the two solutions that we get in that interval, they are going to be x equals 210 and x equals 330. These are the two solutions that we have for this equation, not negative 30 because that's outside the interval that is given. Okay, that's one way to think about this. Now, some people find it a bit confusing because you have a negative value here, and then looking at the symmetry from the negative part of the graph, it becomes a bit confusing sometimes. So I'll give you another way to think about this. And you would most likely find that relatively easy to understand. Let me explain that other way. And I would prefer, so I just wanted to tell you about this as well, using the negative side. That's one way you can approach it. But another way to think about this could be that you do not consider the negative side at all. Okay, now if we don't do that, how else do we figure this out? Let me explain that. Okay, this is another way to think about that same question now. You do the same thing as before. You have this equation, sine of x equals negative 1/2. You put on your calculator sine inverse of negative 1/2. You get negative 30 from that. But now you realize, okay, this is negative 30. This is outside your interval. The interval is from 0 to 360. You are getting negative 30 from your calculator. And the graph that you have is also from 0 to 360, right? This is the graph that you have. It's going from 0 to 360 here. Whatever is the value that you get on the calculator, if it's a negative value, what you are going to do is you're going to add 360 to that. Okay. If it's a negative value, you add 360 to that. Okay, so let me write that value from the calculator. This is from calculator. This is the value that we're getting. What you're going to do is you're going to say, let's add 360 to that. This is outside the interval, right? This is negative. If you get a negative value, you add 360 to it. Now, when you do that, what do you get? X equals minus 30 plus 360. That's 330. And that will give you one solution. 30, negative 30 plus 360. That's one solution. That's 330. That's one solution on this graph. Let's mark that. Where is 330 going to be? 330 is this point here. 330 is this point here, right? This is one solution that we're getting at minus 1/2. What other solution do we have then? Let's go on the left side. This is the other solution that we're getting. This at that same y value, we have this other x value. Now you can use the symmetry like before. What's the distance from 360 to 330? That's 30 degrees. It should be the same distance on this side. So what does this point become then? 180 plus 30, that's 210. So the other solution that you get is 210. So if you get a negative value from your calculator, all you have to do is add 360 to that, mark that point on the graph, and then using the symmetry, you'll get another point on the graph as well. Okay, I hope that makes sense. Let's take another example of this with a negative value. So what if you have sine of x equals negative square root of 3/2 now? So now we've got this. Sine x equals negative square root of 3/2. How do we solve this equation? Again, we put this on our calculator directly. That gives us sine inverse of minus square root of 3/2. Okay, let's see what we get from that. Sine inverse of negative square root of 3 divided by 2. I'm getting x equals minus 60. Now, if you get a negative value, what you're going to do is you're going to say, let's add 360 to it. Okay, you add 360 to the negative value because this is not going to be on your graph. They want the interval to be from 0 to 360 degrees. You want to write down the answers within this interval. If you add 360 to that, you get x equal to 300. That's one solution of this equation. Okay, that's one solution. How do you find the other solution now? You can think of the graph again. What does the sine graph look like? Let's quickly sketch that again. So I'll redraw this and not use the earlier one so that, again, we get used to drawing it quickly. This is the y-axis, this is the x-axis. How does the graph look like? It has to start from 0 and at 360. In the middle, we have 180, we have 90 here, and then we have 270 here. It goes from minus 1 to 1. It's between minus 1 and 1. Now the sine graph starts from 0, goes to 1, back to 0, and then minus 1, and then 0 again. So the graph is going to look like this. This is the shape of the sine graph. Now you've got one solution on your graph already. That's 300 degrees. Where is that going to be? To the right of 270, right? Somewhere here. This is 300. Okay. This is one value that we're getting on your graph. Where's the other value? On the left side here, this value. What's this value now? Again, you can use the symmetry of the graph to figure this out. What's this value going to be? You can see the distance from 270 if you want. From 270, it's 30 degrees on the right, the first answer. The second should be 30 degrees to the left. Or you could look at the distance from 360 on the right side. That's 60 degrees here. So from 180 as well, it should be 360 degrees. Either way, this other point turns out to be 240 degrees. And that's what you write here. You say the other x value is 240 degrees. And these are the two solutions that you have for this equation. Make sense? So one solution you can find from your calculator directly. If it turns out to be a negative number, you just make that positive by adding 360. Okay, you add 360. And then you have one solution on the graph. For the other graph, you can use the symmetry. For the other solution, you can use the symmetry of the graph. All right. Okay, now let's look at tan. What if you have an equation in tan? Let's say you have tan of x equal to tan of x equal to, let's say, square root of 3. Okay, so this is the equation that I want to solve now. X is between 0 degrees and 360. Now, let's just put this on our calculator and see what we get first. X equals tan inverse of square root of 3. What's the value of x that we get for that? Tan inverse of square root of 3. This is giving me 60 degrees. Okay, this is one of those common values that you need to remember as well. So square root of 3 is when x is equal to 60. That's one solution that we're getting in this interval. So that's one solution that we've gotten. Now, we need to find the other solution. We can use the graph for that. What does the tan graph look like now? This is the x-axis, this is the y-axis. What does the tan graph look like? Starts from 0, goes to 360. In the middle, you've got 180. Then you have 90 here and 270 here. Now remember what the tan graph looks like. It's undefined at 90 and 270. Do not forget that. Tan graph is undefined at 90 and at 270. So at 90 and 270, you have asymptotes like this. And the graph is going to look like this, and like this, and this. Okay. Again, you need to remember the asymptotes are at 90 and 270. And then the shape of the graph, it looks like this. Okay, that's your tan graph. All right. Now, if this is the graph, we have one solution that is 60 degrees. Where is 60 going to be? 60 is going to be somewhere here, right? To the left of 90. This is one solution that we're getting. Here, the y value will be square root of 3. Now, at the same y value, do we have another x value? Let's go to the right. This is where you have another x value. This was the first one, which was 60. This is another. What is this value going to be now? Let's think about it. This was 60 units away from origin. This is also 60 units away from origin. What is this value going to be? 180 plus, this is 60 units away from 180 degrees. 180 plus 60, that gives us 240. So this other solution, therefore, is going to be x equals 240. One is x equals 60, and the other is 240. These are the two solutions that we have here. Okay. Now, what if it was some negative value? Let's say you had tan of x equal to minus square root of 3 over 2. Let's do it for this one now. Again, let's say the interval is from 0 degrees to 360 degrees. Put this on a calculator. First of all, x equals tan inverse of square root of 3 over 2. Negative square root 3 over 2. Let's put this on our calculator. Now, what does the calculator give us? Tan inverse of square root of 3 over 2. This is going to be 30 degrees. Okay, sorry, square root of 3 over 3, I meant, not 2. That's going to be some value in decimals. We can look at that as well later on. It's minus square root of 3 over 3. That's the equation that we're solving. Tan x equals negative square root of 3 over 3. Tan inverse of this on our calculator, this is giving us negative 30. Okay, so that's what we're getting on our calculator, but it's a negative number. What we do for that is, we make it positive first. How do you do that? We say, let's add 360, because this is outside the interval, right? To get to that interval, we add 360. That's one full circle. So one full circle actually gets us back to the same number again, the same angle again. And this is going to be x equals 330 degrees. That's inside this interval. That is one solution that we have. X equals 330. Okay, now how do you find the other solution? For the other solution, you do a quick sketch again. For the tan function, what is the sketch going to look like? 0 to 360. This is X, this is Y. You've got 180 here, 90 here, and 270 here. At 90 and 270, it's undefined. Okay, so at 90 and 270, you've got asymptotes like this, vertical lines through which the graph is not going to pass. So at 90 and 270, you have these vertical lines. And then what does the graph look like? It goes like this first, 0 to infinity. On the right side from 180 onward, it goes like this, and downwards, it goes like this. That's the tan graph. Okay, again, you need to remember this shape. Now, this is the tan graph. What we have done is we have found one solution that's 330 degrees. Where is 330 going to be? 330 is on the right side here, somewhere around here. This is 330 degrees. And that's going to be this point somewhere here. Okay. Now, what's the other solution? Let's see what other x value we are getting for this y value. Let's go on the other side. This is where we intersect the graph again, right? This value here would be minus square root of 3 over 3. But this is where we're intersecting the graph again. This is the other x value. Now, how do you find that? The first one was 330. How many units away is that from 360? 30 units away. What about this? This should also be 30 units away. So if this is 180, this point here, this should be 150. So that's the other solution that we have. Then we say x equals 330, that's one solution. And another possible solution would be x equal to 150. And these are the two solutions that we've got for this equation. Is that okay? Any problems with this? Any questions? Make sense to everyone? Now, it could be some value in decimal sometimes as well. For example, if you have sine of x equal to 0.7, right? You have this equation, and the interval is from 0 to 360. It'll always be this in your syllabus, 0 to 360. How do you start? You find sine inverse first of all. Sine inverse of 0.7. Put this on your calculator. See what that gives you. Sine inverse of 0.7, and that's giving me 44.4 degrees. That's the value of x that I'm getting from my calculator. Is that in the interval? Yes, it's already positive. It's in that interval. Now we think of the sine graph. What does that look like? Sine graph. Remember the shape? It starts from 0, goes up to 360. This is x, this is y. In the middle, we have 180. On the left side, we have 90. Here we have 270. The sine graph goes between -1 and 1. It has to start from 0, go to 1, and then 0 again, -1 and 0. This is what the sine graph looks like. Okay, this is the sine graph. One answer that we're getting is 44.4 degrees. Where is this going to be? This is going to be to the left of 90, right? Between 0 and 90. Let's mark that somewhere here. Let's say it's this point here. This is 44.4 degrees. Okay, now this is one solution. Where's the other solution going to be? For the same y value, we have another x value here. What's this x value going to be? Again, we can use the symmetry of the graph. Whatever is the distance from 0 to this point, it should be the same distance from 180 to that point. What's the other value of x that we get? It's 180 degrees minus 44.4 degrees. Because of the symmetry, you can see what that is. That's 135.6 degrees. That's the other value of x. We've got x equals this and x equals this. This is the solution to this equation. All right. Sometimes you can end up getting something easier than this. For instance, you might have sine of x equal to -1. Sine x equals -1. Now, what about this? If you put this on your calculator directly, sine inverse of 1, let's see what we get from this. Sine inverse of 1, sorry, -1, that's giving me -90. Okay, so x equals sine inverse of -1. That's -90. Now, if it's a negative value, remember what we used to do? We would say, let's add 360. Okay, if we add 360 to it, we get x equal to 270. That's one solution that we have in that interval, 270. Now, think of the sine graph. What does that look like? Again, 0, 360, 180, 90, 270. We've got x-axis here, we've got y-axis here. And we've got 1 here, -1 here. It starts from 0, goes to 1, and then 0, and then -1, and then back to 0. The graph is going to look something like this. This is what the graph looks like. Okay. Now, where's 270? 270 is exactly this point here. And at 270, we know that the y value is -1. Now, there's no other value corresponding to this point. As in, at the same level, there's no other value. So this is the only solution that we have for x in this interval. The only solution is x equals 270. Okay, that's the only solution. Then what if we have cos of x equal to 0, for instance? Let's put this on our calculator and see what that gives us. X equals cos inverse of 0. Cos inverse of 0, that's 90. Okay, so that's one solution that we're getting. What does the cos graph look like? You can actually do it without the graph as well. This question here, if you remember the values of cos, if you can just visualize what the cos graph looks like in your head. Cos starts from 1, it goes to 0, and then -1, and then 0, and then back to 1. So the graph is going to look something like this. It goes like this, 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 and this. Where is it equal to 0? Now, we did not even need a calculator for this because this is one value. This is 90. What's the other value? That's 270. It's on the graph there directly. X equals 90 and x equals 270. These are the two solutions that we have from the graph. Sometimes it's one of those special values at an interval of 90 directly, which you can see from the graph and write down the answers directly. For all the other values, we can use the symmetry of the graph to find the solutions. Any quick questions on this? Any problems? Because that was one last thing that we were left with in this topic. Are there any problems with this? Any questions on this? Anyone? No problems? Okay, so we're going to end trigonometry here. Okay, so that's all that we need to know on this. In the last 20-25 minutes, what we're going to do now is we are going to do one other very small topic. Okay, one small topic, and that's angles in a polygon and angles with parallel lines. Let's do that quickly.